So we are given a matrix 4 minus 1 2 1, which is being multiplied by m, and it equals 6 into I, where m is a matrix and I is the unit matrix of order 2 by 2. So this I is a 2 by 2 identity matrix. We are asked to state the order of matrix m, and we are asked to find the matrix m. So the very first thing that comes to my mind is, let me call this matrix A. So if I call this matrix A, then what I have is A times M equaling 6I. And yeah, you can notice that the matrix A is of the order 2 by 2, so it has dimensions 2 by 2. And I is the unit matrix of order 2 by 2, so it is given to be 2 by 2. And 6 times I will just be the scalar multiple of I, so it will again be 2 by 2. And from this for this multiplication to be defined, the number of rows for this multiplication to be defined, the number of rows of m should be equal to the number of columns of A, which is 2. And the result will be then it will have the number of rows of A and the number of columns of M. So if the result is 2 by 2, the number of rows is here 2, and so the number of columns should be 2 as well. So it just shows you that this matrix multiplication is well defined, and the matrix multiplication is well defined, and the product will be a 2 by 2 matrix. So we have actually solved the first question. The order of matrix M is 2 by 2. So I can state this as 2 by 2. Now we need to find this matrix. So if I were to erase everything, let's see. So we have the matrix M. We have the matrix this first matrix 4 minus 1 2 1, which is being multiplied by M, and it is giving me a product of not an identity but a scalar multiple of an identity. So what comes to my mind, the first thing that comes to my mind is that M will be some form of the inverse of this matrix. So even before finding the inverse of this matrix, so let me see if I can, this is the matrix. Let's call, I've already called this as A. So I can I find this matrix is in this matrix is inverse. So if this matrix will have an inverse if its determinant is non-zero. So let's find its determinant first of all. So determinant of A is nothing but the determinant of this 4 minus 1, 2, and 1. So its determinant is nothing but this 4 multiplied by 1, which is 4, and minus negative 1 times 2, that's minus negative 2. So that's a plus 2. So this is nothing but the determinant is equal to 4 plus 2 is equals to 6. So if the determinant is non-zero, that means the inverse exists. And one way to find the inverse is, so let me see if I can find the inverse over here. The inverse will be just A inverse will be just, okay, let's see, 1 by the determinant times the adjoint of this matrix A. And we know a very simple method to find the adjoint of a 2 by 2 matrix. What you do is you swap the diagonal elements. So the diagonal is 4 1, you make it 1 4, and then you make the non-diagonal elements the negative of what they are earlier. So if this is a positive 2, you multiply it by negative 1, so it becomes a negative 2, and this negative 1 becomes a positive 1. So you just change the signs of the non-diagonal elements. So what I have here is, so this matrix is nothing but the inverse of A, and my property, property of the inverse is that if you multiply it with either sides with the original matrix, you get the identity back. So what I can do here is can get rid of this, and I can actually let's see, I can copy paste this. Oops, this just this, and put it over here. So oops, I can this right over here. Let's see this. Yeah. So what happens is I'm claiming that when you have the original matrix multiplied by its inverse, you get the identity back. And yeah, this is the first of all, this 1 by 6 is just a scalar, so I can get rid of that by multiplying both sides by 6. So this goes away. Oops. And this gets multiplied by 6, and this is very much like what I have in my original question. My original question has my original matrix A being multiplied by M, which equals 6 times I, and here I have 6 times I. So what I can claim now is that this is my matrix M. So this matrix M, if I were to write my final answer, would be nothing but 1 minus 2. So this is a 1 and a 1 4. This is my M, and we are done with the question.